Hello everyone and welcome to MES's e-learning channel. So in this video we will be learning Opamp as an inverting amplifier in closed loop configuration. So here I have drawn the diagram. So we can see that these are the two input terminals. One is the inverting terminal denoted by a negative sign and the non-inverting terminal is denoted by a positive sign. Let's call the non-inverting terminal as V1 and the inverting terminal as V2, and the difference in these two voltages, input voltages, VID. So VID is the difference in input voltages and the output voltage is VO. Now why are we calling this as an inverting amplifier? Because we can see that the supply source Vs is connected to the inverting terminal, which is V2, and you can see the negative sign over here. So since it is connected to the negative or to the inverting terminal of Opamp, it is called as inverting amplifier. And why is it called a closed loop configuration? Because we can see that the output is connected to the input side. We can see through a resistor RF. So this is nothing but a feedback path which exists between the output and input. So since feedback is present, this is called as closed loop configuration. Now we know that output voltage for Opamp is equal to the gain of Opamp, which is denoted by A, multiplied by the difference in input voltage, which is VID, and VID is equal to V1 minus V2, right? Now we know that a concept called as virtual ground exists in Opamp. Now this is because of the input resistance. The input resistance in case of Opamp is very high. In ideal case it is infinity, and in case of where we are using a practical Opamp, it is almost equal to 2 mega ohms. So the input resistance is very high, and hence no current can flow inside from the input terminals of an Opamp. Now we can see that a supply source Vs is connected here, hence current I starts flowing from here, current I. Now at this node over here, the current should split, the current should get divided, but since the input resistance between these two input terminals is very high, no current is going to get inside the Opamp. Hence the current I in total starts flowing in the feedback path through resistor RF. So now let's see what V1 and V2 will be. Now you can see that V1 is connected directly to ground, and since V1 is connected to ground, V1 is equal to 0 volts. And since virtual ground exists in Opamp, as V1 is equal to 0, V2 is also equal to 0 because of virtual ground. Now we have to see what the input voltage is equal to and what the output voltage is. Okay, now we have to find out the closed loop gain of Opamp. So in general terms, we know gain is always equal to output upon the input. Now here in this case, the output voltage is equal to VO and the input supply source is equal to Vs. So A, or the gain, is equal to VO upon Vs. So when we have to find out A, we will have to find out VO and Vs. Now let's see what VO is equal to. Now VO is equal to minus I into RF, because we can see that current direction is opposite, hence this minus sign exists and I is flowing through RF. So voltage VO is present across this path where RF exists, hence VO is equal to minus I into RF. Now we got this from this equation, which is the Ohm's law. Now we got VO. Similarly, we will find out what is Vs equal to. So Vs is over here and it is present across this resistor R1, and the current flowing through R1 is I. So, Vs is equal to I into R1. Now, the direction of current is not opposite, hence no minus sign exists here. So, Vs is equal to I into R1. Now, we got both Vo as well as Vs. So, let us substitute these values and get A. So, A is equal to Vo, which is minus I into Rf, and Vs is I into R1. So, I and I get cancelled out, and A is equal to minus Rf upon R1 in case of inverting amplifier. So, this is the gain of inverting amplifier. Let us see the waveform for Opamp as an inverting amplifier. So, the input that we give to an Opamp is a sine wave. Now, let us just consider one cycle of sine wave. Now, suppose this is the input of the Opamp. So, this is the input signal, and output Vo is equal to gain into VID, difference in input voltage. So, gain over here is minus Rf upon R1 into VID. So, whatever is the input difference in the input voltage multiplied with the gain is going to be the output, plus there is a negative sign over here. So, you will get the reverse of the input signal. So, in the positive half cycle, which is for the input, we are going to get a negative half cycle because of the negative sign, plus we will get some amplification. So, amplification. Now, here in this time period, we have negative half cycle. So, we will be getting a positive half cycle in the reverse direction. So, this is how you get amplification of the signal, but in reverse fashion, because we are giving input to the inverting terminal of the Opamp. So, I hope you understood this. Thank you for watching.